Hello everyone, my name is Awabakib and today we'll be discussing and solving Specimen Paper B for Computer Science, IGCSE and O-Level both. And we'll only be looking at the 15-mark question. And I've also solved the Specimen A 15-mark question. You can find it in the other video. And I'll be sharing the Google Colab link and the example file that I'll show you in the description as well. All right, so first of all, let's thoroughly read the question. And once again, it's always advised that you spend at least 15 to 20 minutes on understanding the question in the exam. Okay, so we have names of patients saved in a 1D array called patient. And by the way, I'm assuming that you are well familiar with 1D array and 2D array and the pseudocode basics because I won't be really explaining them in detail in the video. And then you have the 2D array called readings, which stores the latest data about the patient. The array already contains the data. That means you are not going to take input of the data or you're not going to initialize or redeclare the array. All right. And the two things that are saved in the 2D array are the temperature and the pulse rate. And then you have these criterias that the temperature reading should be in this range and pulse should be in this range. Then they're telling you that the hospital number given to a patient is used for the index on both arrays. That is the value between 1 to 1000. So this is really helpful as they already told us that this is the maximum index of the array that you can have. All right. And then when the patient is checked for a warning, okay, we'll get to this, then write a procedure using pseudocode or program code that meets the following requirements. Takes the hospital number as a parameter. Okay, I'll explain what a procedure is and the parameter, and then checks if the number is valid, outputs an error message, and then you have to, if the hospital name is number is valid, then you output the patient's name. You output normal readings if both are within the range, and if then one of them is outside the range, then you give warning, and then if both are outside the range, then you write severe warning, and then you exit the procedure. You must only use pseudocode or program code, and you need to add comments to get full marks. By adding comments, we mean that you'll be writing helpful notes on the way, okay, which is not part of the code, which are not part of the code, your pointers and the comments. And then again, you do not need to initialize the array. All right. So first of all, as I always advise my students, is that you need to visualize the problem on the paper. Okay, you need to draw the diagram. You need to come up with a flow chart or however you want to visualize, but always just draw the arrays and assume some random values in it. And that is what I'll do, and I'll show you right now. So I made these both arrays in a spreadsheet. I'll share this as well. So you have the patient array, and the patient array is a string array. Okay, it contains these patients as strings. So you have these names. Okay, Messi, Ronaldo, Neymar, and Thanos. And then you have a 2D array called readings. And then in the 2D array, it says temperature and pulse are saved. So it should be very obvious to you that this is how the 2D array would look like. Okay, the first column would contain temperature and the second would contain the pulse. They've not really told you which one should come first, but because they've written temperature first, so we're assuming that it's in the first column. Even if you swap them, it doesn't make much of a difference. Okay, so you have 1000 rows in total. They've explained you this. Okay, and then the most important part here is the mapping, that the names in the 1D array would map to the same index on the 2D array. Okay, so let's say if we have uh, Naruto here, Naruto is at the 6th index of patient. Similarly, we'll map the same logic here and we'll know that Naruto is also at the 6th index in the readings array, and then the temperature and pulse are given here. All right, the same thing for Thanos, same thing for Messi, same thing for Ozil, stuff like that. So whatever patient name you have and you get the index, using the same index you can access their temperature and their pulse. So now if this is clear to you, then the question is pretty straightforward. You do not even need any sort of a nested for loop here because they told you that the hospital number would be given as a parameter. Okay, so you'll only be checking for that specific hospital number. So the hospital number is given to the patient that is used for index on both arrays, and this is the value. So this is the mapping part that I was talking about. Okay, so you do not need to use a nested loop here because they are directly telling you, okay, we want you to tell if the patient number 6, what warning should you print for them? Are they normal or are they on warning, or are there some sort of severe circumstances going on? All right. Same for all the patients. So you'll just input one patient name. Okay. Again, you are not going to go through the whole array, because if you look at the section, sorry, specimen 2A, we were basically iterating the whole 2D array one by one. Here you won't. Here they'll just give you the input of the hospital number, and then you'll directly use that. Okay, so let's look at the code directly now. First of all, what is a procedure? So if I were to tell you what a procedure is essentially just a block of code. Okay, so procedure is essentially a block of code that can be reused multiple times in a program. All right, so you don't have to call the sorry, you don't have to rewrite this code over and over again. Let's say you need to check the patient multiple times during your program. So one way would be that you just copy paste the code, or other ways you just call the procedure. How will you call the procedure? Below somewhere, maybe in the next block, you'll say uh, call, and then you'll put the procedure name, which is the name of the procedure would be, what did we call it? So let's check patient. All right, so you'll say call, and then you'll say check patient, and in the brackets you actually have to pass an actual value. Okay, this is just a placeholder value. This is what we call the parameter. These are the values that are needed to make the function or procedure run. Okay, so here you'll pass an actual integer value. Let's say I check hospital number, sorry, yes, hospital number 5. So for hospital number 5, I'll go to my dummy data and I'll say this is Aaron, and for 5th, this is his pulse and this is his temperature, 30 and 89. And depending on the criteria that are given to us, the ranges that are given to us will print something. All right, so you can do the same thing. Maybe next time you want to check on another patient, you can just directly input the patient number. So this will return you something. So you are not copy pasting the code, right? You're just calling the procedure from the above. So again, this is a block of code that can be used multiple times without actually rewriting the whole code. And we use this for the concept of decomposition, where we break down the problem into smaller parts. All right. So I'm taking this away. All right. Now, first of all, as always, we need to declare the variables and the constants. Constants are always optional. You don't really need to write them as such. You can just use the direct values 37.2, 31.6, but it's always a good idea because it gives a better and a neater readability to your code. All right. So we write the procedure, we call it check patient, and then we take the procedure hospital number as a parameter. That is what I've done as an integer. Then the first thing is you check if the hospital number is valid. How do we do that? We make sure that it is between 1 and 1000 inclusive. So I check if the hospital number is greater than equal to 1 and less than or equal to 1000. Then if that is the case, you will run the code. Otherwise, they're saying otherwise you have to output an error message and exit the procedure if the number is not valid. So if the number is not valid, I'm simply saying else, and I'm saying hospital number not valid, end if, and I'm ending the procedure. And you can actually look at these lines, the white lines. You'll see this else is actually in line with the this if condition. So if this if condition is not true, you'll directly go to line 46. All right. Okay, if this is true, then you output the patient's name. This is the name of the patient. The name of the patient is patient, hospital number, again using the same logic that I told you. So let's say the patient name in this example will be assuming that the user passed 5 here. Okay, when we called the function, we called 5 here, right? So we're talking about this now. So hospital number was 5, and at 5 we have RNG here. So here we have 5, and the name of the patient would be, so what is at the 5th index of the patient? It is Aaron, so Aaron would be printed. Then okay, so this is an extra step. You don't really have to do this. I just did it to reduce the code and again to improve the readability. Otherwise, you would have to constantly rewrite reading brackets HPT num1 to again reading HPT num1 2. So rather than that, I just assign them to two variables and I just use those variables in the program. Okay. But you can also, if you want, you can just get rid of the variables and you can just replace current temp with the actual value directly. But this is better. I would recommend you do the same. All right. So current temp. What am I doing here? I'm saying that okay. First, you need to just a quick refresher that 2D arrays notation is that you have the array name followed by square brackets. Then you have the row number, comma, and you have the column number, right? So here we have the HPD number. Hospital number is the row number. Again, because we have the same mapping as I told you in the questions, that the row number 5 in patient is also the row number 5 of Erin in the readings, giving his temperature and pulse. So how do we get the temperature? Because we assumed that the first column is actually the temperature. So fifth row, and for the temperature we find that Erin is 30 degrees Celsius right now. And if we look at the pulse, that is 89. All right, so this would be replaced by actual values. This would change to a 30 and this would change to an 89. So you get the idea. So the one here is representing the first column and 2 is representing the second column. We have hard coded this because we know that temperature is in the first and the pulse is in the second, right? All right, so moving on, the next thing we have would be, now we have to check for the conditions if they are met or not. So look at the first condition. Output normal readings if both readings are within the range. So the temperature and the pulse, they both have to be in the same uh, range. They have to both meet the normal reading. So how do we know the normal reading? This is the range, 31.6 to 37.2 inclusive and 55 till 100 inclusive. So I assume them, I initialize them in the start, so I'll be using the same value. So I'm checking if the current temperature is less than or equal to temperature high and the current temperature is actually greater than or equal to temperature low. All right, so it's in the range that the value is between this. So an example could be maybe uh, 32 or 34 or 36. Okay, so if this condition is true, then you further check if the pulse is also in this range. So I check if the current pulse is less than the maximum allowed and the current pulse is greater than the lowest allowed. If that is true, then you'll say sorry. So if current pulse is less than pulse high, it's lower than the maximum allowed and greater than the lowest allowed. So you say normal readings. Pretty simple. In the next part, you are going to check if there is any sort of warning. So warning would be shown if one of the reading is out of range. So you actually have to check both. That one of them could be true and the other one could be false. So maybe the temperature is uh, not okay while the pulse could be okay, right? Or the pulse could be not okay and the temperature could be okay. So you need to look at both of these cases. Again, if you have an idea about and or operators, so this is pretty much the simple Boolean logic. Okay. So here what we do, first we check if the current temperature is actually in the range, exactly the way we did before. So if the current temperature is lower than the highest allowed and is greater than the lowest allowed, so we know that temperature is fine. And then you'll check for the pulse. So if the pulse is either higher than the maximum allowed or if it is lower than the lowest allowed, then you are going to print the warning pulse. All right, and then you end if the inner if and then the outer if. Simple. Then you have to repeat the same thing for the temperature. So let's assume that the temperature is not fine. Okay, so in fact this should be the other way. Okay, first we'll actually check if the pulse is fine. So I'll just copy paste the pulse condition from here. All right, so first we'll check if the pulse is fine from this. Yeah, I'm just pasting the pulse. So we're assuming that the pulse is fine now. All right, so if the pulse is fine, first we check that. And then we check if the temperature is either higher than the allowed, maximum allowed, or it's lower than the lowest allowed. If that is the case, then you print the warning of temperature. And then you end if the inner if, and then you end if the outer if. All right, same logic. First we're checking if temperature is fine, and then we're checking if pulse is not okay. Then here we're checking if pulse is okay, and then the temperature is not okay. And then for the last part we have, that is the severe warning and the names of two readings if both readings are out of range. So for the both readings you just have to use this simple or. So if either the current temperature is greater than the highest allowed, or it's uh, lower than the lower allowed, and then you check if the current pulse is greater than the highest pulse allowed and it's lower than allowed, okay, the lowest pulse allowed. So then you'll print severe warning, pulse and temperature, because they've asked us that you have to actually print a warning related to these two, and then you enter. All right, here you're checking for both of them that these two must be um, met for it to be a swear warning. We can rewrite this a little bit. We're checking if either of these are high, and then we'll say and. Okay. So if the temperature is out of range and the pulse is also out of range, then we print these two. Multiple ways of writing the same thing. All right, so I'll keep it this way so it's coherent. And that's pretty much it. Um, let's look at the question again. Exit the procedure otherwise, and you print the value, and yes, that's it. Just to make sure that we've added the comments, we have added the comments. You don't need to call the procedure, so I'm taking this away. This is exactly it. So just a quick review. You pass in the hospital number, you check if it is in the range. If that is true, then you'll print the name of the patient using the index given to you. We assign the first column of the hospital number into the current temperature, the second into the current pulse. Then we are checking if the temperature is in the range and the pulse is in the range and it's normal. Then we're checking if the temperature is in the range and pulse is not, then the warning of pulse. Then we're checking if temperature is not in the range, the pulse is in range and temperature is not in the range, then warning. And then we're checking if both the current temperature is out of range and also the pulse is out of range. Okay, so you'll say that it's a severe warning. You can again do this with the nested if, or you can use an and here. It's totally up to you. And this was pretty much the whole part. So if you have any questions, let me know. Again, I'm sharing these files in the link, and good luck for the exam, and I hope you do a wonderful paper.